Okay, this is going to be the second video on converting a function to a geometric power series. And if you haven't done it yet, I would definitely watch the first video because it'll give you a little bit of an insight on the process that we used. Now, just like in that first video, real quickly, let's take a quick look at a geometric series since you'll need this. So we'll follow exactly the same process. You'll be given a rational function, and the idea is to transform that rational function into this form right here, a divided by 1 minus r. Once you've got it in this form, then you can come up with the summation with the geometric series. And once you've got the geometric series, then you can find the interval where it converges. So again, if you're not familiar with this, take a quick look at the first video, and it will catch you up on what you need for this video. So now let's look at a couple problems and see what this looks like. Now, in the last video, we looked at problems similar to this, but it just had an x to the first power not raised to another power. In this video, we'll look at a couple of examples where the x is raised to some power other than 1. Now again, the process will be exactly the same thing. Is given this rational function, 1 divided by 1 minus x cubed, I want to transform it into this form, a divided by 1 minus r. And to do that, I'll use exactly the steps that we did last time. First of all, just go ahead and write the original function. So I'm going to write this as 1 divided by, and I've got 1 minus x cubed. Now, usually you've got to do some work on that, but in this case, remember, you need a 1 right here, and we've got a 1 right there. You need a negative, and we've got a negative. So in this case, this thing is really all set up, so I really don't have to do any work at all on this one. So I think I'll write it one more time. Here's the 1, and I've got 1 minus, and I'm going to go ahead and put it in parentheses. This is going to be x cubed, and it looks like that. Now, just like we did in that first video, once you've got the 1 and the minus, whatever is here is your a, or a sub 0. Whatever is here is the common ratio, r. So you've got it in this form. Now the next step is to transfer it from this form into this summation notation, and let's do that in the next step. So this is going to be the summation as n goes from 0 to infinity. And I like to start by just writing the original rule. So a sub 0 times common ratio raised to the n power. So what that's going to give me is the summation as n goes from 0 to infinity. And in place of a sub 0, put a 1. So I'm going to have a 1 here times. And then in place of r is going to be equal to x cubed. So this will be x cubed. Raised to the n power. Now again, as I write this out, this is a, or a sub 0, and this is r. So I've got the a and the r. Now sometimes they're simplified a little bit. If you check the answers in the back of the book when you're seeing whether you got them right or not, you might end up something like this. 1, and what the book will probably do is go ahead and multiply those two together and make that be x to the 3n power. So it'll probably wind up looking something like that. So what that's going to be the rational function expressed as a geometric power series. Now the next thing is to find the interval of convergence. And the interval of convergence, again, occurs wherever the common ratio is less than 1, and that's true for all geometric power series. Now in our case, r is equal to x cubed, so we'll replace this with the absolute value of x cubed. And we want to know where is that less than 1. Now, since that's a cube, you can think of it as taking the cube root of both sides. That means that x would have to be less than the cube root of 1, which is also 1. And then when you write this in the form, if the absolute value is less than 1, that means that x is less than the absolute value of a positive 1 and greater than the absolute value of a negative 1. So in that case, this is going to be the interval of convergence. Or if you want to, you can write it in the open interval notation, minus 1 to 1, if you like that notation better. And then the radius of convergence is going to be the distance from the center to 1. So in this case, the radius of convergence would be equal to 1. So there's the first example, and it just kind of shows you what to do if you have something other than x to the first power. And the idea is, if it's a cube, take the cube root of it over here. So let's take a look at a second example and see what it's going to look like. So the next example is similar to it, but it's got a few more things here. So we'll do exactly the same process. Now the idea is to take this 2 divided by 1 plus 4x squared and transform it into this form. And again, my suggestion is always start by just writing the original thing down. So I've got 2 divided by, and this is going to be 1 plus 4x squared. Now we use the same process we did in that first video. I'm going to go ahead and make this be, here's the 2, and I'll change this into, now I've got the 1, but I need a minus. Here right now I've got a plus, so I'll make it be 1 minus a minus 4x squared. And what that does, that gives me the 1. I need a 1 and a minus. I've got a 1 and a minus, so I should be good to go. So once you've got it in that form, then whatever's in the numerator here is a, or a sub 0, and this is going to be the common ratio. So you had to get it in this form to find a and r. So now your next step is to take this and change it into summation notation. So I'll start by just writing the rule down, and that's going to be the summation as n goes from 0 to infinity of a sub 0 times r raised to the n power. And what that's going to be would be n goes from 0 to infinity. And again, in place of a sub 0, put what it's equal to. So in this case, it's equal to a 2. Then you've got r. Well, r is minus 4x squared. So minus 4x squared raised to the n power. Now at this point, it's just a matter of dressing this thing up a little bit. So first of all, I think I'll use that same trick that we used in the first video. Anytime you've got a negative raised to the n power, you can actually factor out a negative 1. And you'll see that done almost every time in these problems. So this goes from here to here, and I'm going to change that from a negative 4. I'll factor out a negative 1 to the n power. Then here's the 2, and that's going to leave me with a positive 4x squared. To the n power. But you can do a little bit more with it than that, so let's try this. We'll go one more step. This is going to be the summation as n goes from 0 to infinity. First of all, here's the negative 1 to the n. Then you've got the 2. Now you can also do this. Break this into 4 to the n times x squared to the n. So that's going to be, I'll put it right here, 4 to the n. And then finally, in the last term, if you take x squared raised to the n power, multiply the exponents, and that'll give you x to the 2n. So there's a pretty good chance that the final answer is going to look something like that. So what that does, that transformed this function into a geometric power series. Now the next question is, what's the interval of convergence? So again, we'll go over here and we'll start with the interval of convergence is always the absolute value of r has to be less than 1. That's just the definition of the interval of convergence of a geometric series. Now in our case, rather than looking over here and trying to find r, come back up and get it right off this. So what I usually do is, in that initial step, this was a and this was r. So in your initial step, whatever's in the parentheses, use that as your r. So this is going to be the absolute value of minus 4x squared has to be less than 1. Now again, when you take the absolute value, that negative is going to disappear. The next thing to do is factor a 4 out of that. So that's going to be 4 times the absolute value of x squared is less than 1. And then we'll kind of bring it up over here. The next step, divide both sides by 4, and you'll get the absolute value of x squared is less than 1/4. Well, if the absolute value of x squared is less than 1/4, I'll take the square root of both of those, and that's going to give me the absolute value of x has to be less than, and the square root of 1/4 would be 1/2. So I'll wind up with that. So 1/2 here. Okay, now if the absolute value of x is less than 1/2, that means that either x is less than a positive 1/2, or x is greater than a negative 1/2. And that's going to be the interval of convergence. Again, you can write it as an open interval if you want to. You could write this as the interval from -1/2 over to a +1/2. You could also write it in that form. And then also the radius of convergence is that. So that's going to be, so the radius goes from 0 out to 1/2 or 0 out to -1/2. So the radius of convergence would be 1/2. So again, there's just a couple of examples on how to handle the problem if you have x to some other power than 1. And really, it's not a lot different, but follow the same process. Just start by changing the original function, transform it into this form. That's going to give you the a and the r. Then you can write it in summation notation once you've got the summation notation, and you'll always use this to find the interval of convergence. So just set the absolute value of r less than 1, and whatever's in the parentheses is what r is. Solve it, and you've got it. So there's a second example. Now, in the next example, so far everything has always just had a number in the numerator. In the next video, we'll look at a couple problems where suppose there's an x or some other variable up here in the numerator.